For the longest time, artificial intelligence was just, well, it was the stuff of science fiction, right? But then, in one specific decade, the 2010s, something just fundamentally shifted. It really felt like we were watching sci-fi become reality right before our eyes. So, we're going to dig into how AI finally woke up and why it all happened so incredibly fast.
And yeah, I mean that quite literally. After decades of just slow, steady progress, AI didn't just inch forward. It just, boom, it ignited. This was not some gradual step forward. It was more like a Cambrian explosion of digital intelligence. And honestly, it changed the entire trajectory of technology forever.
And the crazy part? This wasn't just some experiment stuck in a research lab. No, this revolution was actively reshaping our world. We're talking about intelligent automation on factory floors, predictive analytics totally changing healthcare and finance, and yeah, all those personalized recommendations that pretty much shape our daily lives now. AI, almost overnight, became the engine driving the global economy.
So the technology powering this whole massive shift, it's called deep learning. And the key phrase to hang on to here is automatically extract complex features. See, before this, humans had to painstakingly tell a machine exactly what to look for. The edges of a face, the curve of a wheel. But with deep learning, the machine learns to spot those patterns all by itself. It's kind of like how we do.
Which brings us to the big question, right? AI research has been around since the 1950s. So why the 2010s? What caused this sudden explosion? What was the secret sauce that finally brought all these ideas to life? Well, as it turns out, it wasn't just one thing. Yeah, the answer wasn't some single aha moment. It was more like a perfect storm, a convergence of three totally separate, powerful forces. On their own, they were interesting, sure, but when they all slammed together at exactly the right moment, that's what created the revolution we're still living in today.
Okay, so what were these three pillars? First, you had an insane amount of data to learn from. Second, a new kind of hardware powerful enough to actually process it all. And finally, some brilliant new ways of structuring the AI models themselves. Let's break each of those down.
I mean, just think about it for a second. The internet, smartphones, social media, all of a sudden, humanity was creating this tidal wave of digital data. This was the fuel. See, deep learning models are incredibly data hungry. And for the very first time, we actually had enough to feed them. And things like cloud computing made it possible to store all this data, while open source tools like TensorFlow and PyTorch made it accessible to pretty much everyone.
Okay, so we had the fuel, right? But you still need a new kind of engine. And it came from a pretty unlikely place. Video games. Yep. GPUs, those graphics processing units designed to render amazing 3D graphics, turned out to be absolutely perfect for the kind of math deep learning needs. It's all about something called parallel processing. They can run thousands of calculations at the exact same time. This slashed the time it took to train an AI from months down to just days, or even hours. A total game changer.
But look, having more data and more power isn't enough if you don't have the right blueprint. The final piece of this puzzle was a breakthrough in the design of the neural networks themselves. Scientists developed these new models, like convolutional neural networks, or CNNs, which were just brilliant at understanding images by spotting patterns in pixels. They also came up with recurrent neural networks, RNNs, which were designed to understand sequences, like words in a sentence or notes in a song.
And this really gets to the core of the difference. The old way, if you wanted an AI to find a car, you, the human, had to manually program it. You'd have to tell it, look for wheels, look for windows, look for a metal body. It was super brittle and tedious. With deep learning, you just show it a million pictures of cars and it figures out the essence of carness all on its own. It learns the features automatically. And that wasn't just an improvement, it was a gigantic leap in what was possible.
Okay, so we've got our three ingredients, right? Data, power, and these new architectures. They were all kind of bubbling away in the background, but every revolution needs a spark, that one moment where all the potential becomes just undeniable reality.
And that moment, it came in 2012. This is the year everything changed.
The stage for this was the ImageNet competition. You can think of it as basically the World Cup for computer vision. Teams from all over the world would compete to see whose AI could most accurately identify objects in this huge library of photos. And for years, progress had been pretty slow, just tiny incremental gains.
And then along came AlexNet. It was built by this small team from the University of Toronto, and it combined all three ingredients we just talked about. It used a deep convolutional network, was trained on a massive data set and was all accelerated by GPUs. The result? Well, it didn't just win, it absolutely demolished the competition. Its performance was so shocking, so groundbreaking, that the entire field of AI research just pivoted, almost overnight. This was the proof everyone was waiting for.
So, that AlexNet moment, it wasn't the end of the story. It was the starting gun. The floodgates flew open and suddenly the race was on to apply this incredible new power to, well, everything.
And one of the biggest reasons this tech spread like wildfire was a technique called transfer learning. Think of it like this. You don't have to learn to read from scratch every time you pick up a different book, right? Once you know the alphabet and grammar, you can adapt. It's the same idea here. You could take a powerful model like AlexNet, which already gets the grammar of images, and just fine-tune it for a totally new task, like identifying tumors in medical scans or spotting pedestrians for a self-driving car. This massively accelerated real-world AI adoption.
But of course, when you unleash a new form of intelligence this powerful, this fast, you're going to run into a whole new set of really complex problems. The question quickly changed from can we do it to how far can we push it? And this power immediately kicked off a kind of arms race for scale. The new frontier was all about getting more data, building bigger computer systems, and designing even more massive, complex models. The chase for artificial general intelligence, an AI that can reason and learn across all kinds of different areas, well, that became the next grand challenge. And that pursuit is exactly what brings these tough ethical questions to the forefront.
So, when you look back, the deep learning decade gave us machines that can see, hear, and understand in ways that were pure science fiction just years before. That perfect storm of data, power, and brilliant algorithms, it really did wake up AI. But as we move forward, the critical question for all of us is no longer about just waking it up. It's about what we choose to do now that it's awake.